cover how to know if a table is linear, absolute value, or exponential. So you know a table is going to be linear because it is adding at a constant rate. You know it's going to be absolute value because that slope or that rate of change is going to be the same number with different signs. And then it's exponential if you're multiplying by the same number each time. Let's look at this first table. After we finish and figure out what it is, I'm going to write an equation for each of them as well. So if we look at our change in x's, this is how our x's change as we go across the table. They are adding 1 every single time. So this is our change in x. Our change in y, it looks like it's going down by 2 each time. So each time it's going down by 2. Whenever we have a constant rate of change, and our rate of change is our delta y over delta x, whenever it's constant like this, our -2 over +1, we know that this is going to be a linear equation. And we know that because throughout the whole table, the rate of change is 2 over 1. And it won't always look so simple. Sometimes it'll go up by 2 on your x's and down by 4, but it's still linear because -4 divided by 2 is still equal to -2. So we know that this is a linear table. The cool thing about linear tables is that when you actually make the equation, you can use any point in that table. I like to use the y-intercept, which is 0, -5, because then I can write y equals mx plus b, where m is my slope, which is my delta y over delta x, and b is my y-intercept. And your y-intercept is when x is 0, it's that point that I have circled there. So let's try to make an equation. We'll have y equals our slope, which is -2. If you wrote -2 over 1, it technically isn't wrong, but -2 divided by 1 is just -2. So I always say just -2 times x, and then our y-intercept is -5. So if you were to need the equation for that table, that is what it would look like. Next, our x values seem to be going up by 1 here. And we start by going down 2, then we add 2, add 2, add 2, and add 2. So in this one, we have -2 over 1 as one of our rates of change, and we also happen to have +2 over 1 as our other rate of change. And when we think about absolute value graphs, they are V-shaped graphs, and half of the slope is negative, and the other half of the slope is positive, but the rate of change is identical. So when we have the same number with different signs for our slope, we have an absolute value table. Now, absolute value tables are the hardest ones to make equations from because you have to be very specific about what you use in your equation. We are going to start with y equals, and then we have to use the slope on the farthest right side of our table. So we have to use the +2 over 1. And that's because our graph models our table. So the right side of our table has a positive slope, meaning it's going up 2 over 1, and the left side of our graph has a negative slope, meaning it's going down 2 over 1. So if we said it was -2, that means this graph would be upside down. It opens downward. That's not the case. This graph opens upward because it comes down to this point and starts going up. It's going to open upward, so we want to use the positive slope in our equation. The slope here is going to be 2. Then we have to pick a very specific point. You can't pick any point in this table. You have to pick this point, which is called the vertex. You know that that is the vertex. And remember, the vertex is like the bottom or maybe the top of your graph in some cases. Some cases it might be the top. In this case, it would be the bottom. That's where it changes from our negative slope to our positive slope. That is the only point where it changes from a negative slope to a positive slope. So it has to be what we use in the equation. So we're going to do x, and instead of -2, we're going to write +2. and then we're going to leave our y value as plus 1. So make sure you're doing the opposite of -2 for your x value when you write it in your equation. All right, let's do a couple more here. This one, you might be seeing the pattern for your y values as dividing by 5, but I want to encourage you to look at this one more time. We want a pattern that multiplies here. My hint for this is always to look and see what happened between the 1 and what's right after it. So obviously we must have multiplied 1 by 1/5 because 1 times anything is just what you multiplied it by, right? So I'm going to say, I think we multiplied by 1/5. Let's see if that checks out. 1/5 times 25 would be 5 because 1/5 is this multiplied by 1/5 is the same thing as dividing by 5. So I agree with that. This is times 1/5. Dividing by 5 here, yeah, that would work. Multiplying by 1/5, yep, multiplying by 1/5. All of these are multiplying by 1/5. So when we are multiplying in our table consistently, it's going to be an exponential function. And when we write the equation for the exponential function, we need two things. The first thing we need is our y-intercept. So in this case, it's 25. And the second thing we need is the ratio. I just wrote ration. Sorry. Let's make that say ratio. Excuse me. To make this equation, we'll write y equals your y-intercept, which is 25, times your ratio, which is 1/5, and then you raise it to the x power. That is your exponential function. Let's do another one. These are all going up by 1. Your y values here went up by 2, up by 2, up by 2, up by 2, and up by 2. So whenever we have that constant rate of change, it's going to be a linear function. I am going to use this point right here to make my equation. So I'm going to say y equals, and you want your delta y over delta x. And your delta y's are down here. Your delta x's are up here. So it's going to be 2 over 1, which just is 2. And then I'm going to do x, the opposite of my positive 1. My x value is -1. And then positive 2 is my y value. So that's my equation there. And that's a linear function. All right, let's try this one. Here we're going up by 1, up by 1. Looks like every time we're going up by 1. And then let's see what's happening to our y values. I typically like to start where I go from 1 to something else. Because if I'm going up by 1 on my x value, I'll pretty much immediately know what my y values are doing. So it looks like I'm going up by multiplying by 2. Yep, 2 times 2 is 4. 4 times 2 is 8. Let's see if it works here. 1/4 times 2, and I can show this off to the side if you need to see it. That's 1/4 times 2 over 1 is 2/4, which equals 1/2. And then 1/2 times 2 is going to give you 2 over 2, which is 1. So our ratio here is going to be times 2, and our y-intercept, which we need for our equation, is going to be 1/2. This is exponential because we are multiplying. To make our equation, we write y equals our y-intercept, which is 1/2, times our ratio, which is 2, and you raise it to the x power.